Okay, so on Thursday, we started off with a problem like this. I left you guys to try to figure it out on your own. Did anybody make any progress or see where to start on it at all? No? Well, we have an arc of a circle here. Remember, one of the things we always do is we look for a radius to the arc of a circle to create a right angle. So let's say I create this radius. Now, we don't necessarily think that, we don't know that the center of that circle is on the edge of the slope here, so we can't arbitrarily put it there. We're going to put it out here in the middle somewhere, and maybe it's going to end up there. So we have that right angle right there. The question is, what does that tell us? What do we know about it? So let's see what we can figure out for angles. First angle I'm going to find this angle down here. Anybody have any ideas how I could find that? Well, we have the slope ratio here. If I draw a triangle out, that would be saying that it'd have a height of 3, a run of 2. This angle should be the same as this one here. So the 3 and the 2 make the opposite and the adjacent sides, which means I'd be dealing with what trig function? Tangent. Tangent of theta is opposite over adjacent. And then I fill in the information I have. I'm looking for the angle, so I don't have that. Opposite side is 3, adjacent side is 2. So the angle I'm looking for here is the inverse tangent of 3 divided by 2. So second tangent, 3 divided by 2. 56.31 degrees. And that'll, of course, be the same angle over here. Any other angles we could find? We know we can find the top one. What I'm going to do is I'm actually going to cut it like this, because it's going to be more useful to us like that. And half of that top angle would be 33.69 degrees. This angle right here would be nice to have. Is there a way we can find it? Well, there is, but to find it, we would have to have this angle right here, which we can find off of this aspect ratio here. This is a 1 to 6. This angle right here, then, is going to be found. Again, we have opposite and adjacent sides, so that's going to be tangent. So the angle is the inverse tangent of 1 over 6. So at 9.46 degrees. So that's this little angle right here. Which gives us this angle here is what we were looking for. It's going to be 90 minus the 9.46 and minus the 33.96, which is going to give us, what, 46.85? Sound right? So 46.85 degrees there. Well, what does that do for us? Let's keep going. I can do a similar thing down here, I suppose. That's a right angle. This one's pretty simple. It's just going to be 33.69. Does that do anything for us? Maybe. Who knows, right? Well, let's keep going here. I am going to look at this slope line here, and I'm going to draw a right triangle in there. Remember, one of the things we said we could do is we could draw in vertical or horizontal dimensions, and a vertical and a horizontal dimension will always form a right angle with each other. So we're looking at this right angle here because we drew this across here horizontally. So looking at that triangle, we do know that this is 10 millimeters here, because wherever these two cross is going to be the center of that circle. So we do know the hypotenuse of that triangle. Do we know any of the angles? Well, yeah, we actually know this up here is 9.46 degrees. That angle here has to be the same as this one up here. So what we can do, let's find this height and this height. I'm going to give you guys a second. Find, I'm going to call this A down here and this B. Find those in your notes quick. So what'd you come up with? For B, 9.8634. Or 9.863. For A, 1.644. Sound good to everybody? What's that? 1633. Here, we'll double check it. I'm getting 1.644. Okay, so we have those dimensions. So the question keeps coming. What good do they do us? Where do we go with them? Well, there are a few dimensions here that we know. We know this has to be 42. Half of the 84, right? This height here has to be how much? How do we find the height? Slope. Okay, how would we set that up then? 42 goes on bottom. Yeah. So we cross multiply and divide, and we get that to be 63. So this is a height of 63. If we could somehow build those dimensions from pieces over here, for example, we know the height of 63 would be y plus that 9.863 we just found, plus whatever this height here would be. So let's take a look at that height there. How would we describe that? Well, this is x right here, correct? We know that that is, this angle here is 9.46 degrees, correct? So this height over here is the opposite side. X, of course, is the hypotenuse, which means we're dealing with a sine. Sine of 9.46 degrees equals that opposite side over x. Make it a proportion and we cross multiply and divide. That height is simply going to be x times the sine of 9.46 degrees. Sine of 9.46 is just a decimal 0.1644 x. So that height of 63 degrees or 63 millimeters here is y plus 9.863 plus 0.1644x. 9.863 that adds up to 63. Well, there's two variables there. We can't solve it. When we have two variables in an equation, what do we need in order to solve to find the value of the variable? You need somebody said it, a second equation. So where are we going to find the second equation? Oh, this equation was the vertical dimensions. We're going to use the horizontal dimensions. So over here, what we have this dimension right here will come off of the same triangle that we were looking at here. So let's find this one here. This would be the adjacent side. So that would be cosine. So if we solve that one, cross multiply and divide, we get that x times the cosine of 9.46 equals that adjacent side that we're looking for. So the cosine of 9.46 0.9864 that is the dimension from here to here. Now we need to get all the way out to, oops, wrong color. We need to get all the way out to here. So we need this leftover piece here. How far is it from there out? 10, right? But we're overlapping by this much, which happens to be our 1.644. So the dimension x here is, or this dimension of 42 here, is going to be this piece plus 10 millimeter radius minus that overlap. So we had 0.9864x minus that overlap of 1.644 plus the radius of 10, and that adds up to 42. Well, that equation actually worked out to be just one variable. So we can actually solve that one for x. I'm going to combine negative 1.644 and 10 to get 8.356. Subtracting 8.356. 0.9864x equals 33.644. And then dividing by 0.9864. So x equals 34.11, we're going to call it. So we found x. Now what? Put it back in here to find y. Very good. So y plus 9.863 plus 0.1644 times 34.11 equals 63. So I'm going to combine all this. 9.863 plus 0.1644 times 34.11. Oops, before it register. So 15.471. And we subtract. So y equals 47.529. What do you think? Good stuff? No?
Bit much.
It's a bit much.
Bit much for Monday morning.
Well, I like that one because you didn't necessarily need the system of equations, but it does kind of have that little bit of a reminder of those things. Those systems of equations do come up, and they are still very important. What's that? Well, only because you don't do them often enough to remember how to.
Yeah.
That one worked out really nice because one of the equations only had one variable, so you could solve it. Substitute it in. I try to be nice sometimes. Problem number 2. Anybody make any progress on that one? Weren't you guys energetic over the weekend, huh?
I was energetic over the weekend.
Yeah, well, if you were energetic over the weekend, these would have been done before you got here today. Okay, well, let's see what we can get going here for you. Of course, we've got the right angles at the tangents to the radius. And, of course, we're going to find an angle here, which is going to be from the 1-4 ratio. Find that angle for me, at least. So, yeah, we're looking at the inverse tangent of 1/4, so we get 14.04 degrees. So, what does that tell us? That tells us that this here would be all 14.04 as well. Same here. Which means this total angle here is going to be 180 minus the 28.08. So 151.92 degrees. Now what? Well, I'm going to argue we can find this distance really quick, distance y. Can you tell me how? We could. We can use a lot of cosines too. We've got two sides and the angle in between them. But we can make a right triangle. This angle here is going to be 75.96 degrees, correct? So now, if we're using that, we got this triangle here, 75.96, and this is 44. And we're looking for this dimension here. So that's the opposite over hypotenuse. That's going to be a sine. So plugging in our information, sine of 75.96 equals, we'll call that A for now, A over 44. Cross multiply and divide. 44 times sine 75.96. 42.69 it looks like. In fact, what I'm going to do is I'm just going to take that number and multiply it by 2. 85.37 is y. So now with that, remember we can cut this straight down through here. We should hit the middle of this 48 at 24 millimeters. If I find this height here, which is going to be from the cosine, and I'm just, in fact, you guys find that height for me. What did we get for B? What's that? 10.67? Okay, so 10.67. So I'm going to draw this out here. We have that 10.67 right here. It's above what I'm drawing out. We had, what, 42.685 here. 24 down here. I can cut this right here. This was 1404. Yep. This, I'm assuming, is also 24, since that's a rectangle. Leaving us with 18.685 here. what does that give us? Well, we can use that to find this height right here. So go ahead and find that height for me. I'm getting 74.74. Anybody else get the same or something different? Yeah, close enough. All I did, by the way, I didn't even pull out the trig function. This is a 1:4 aspect ratio. Just multiplied by 4. Started getting buried in the trig, you missed the easy parts. So anyway, x is now that plus this plus the radius of the circle. So I'm going to assume you guys can add up those three numbers to find x. Total area is sitting out there for you guys to find on your own. And now, good news. Other than finding that total area, there won't be any new homework for tomorrow, because I'm about to give you